Waterfall, waterfall. Today, we are learning about the observable properties of solids, liquids, and gases. But before we do that, can anyone give me an example of what a solid or liquid or gas might be? Sophia.
A solid is a brick.
Amazing.
A liquid is water.
Awesome. Do you have one for gases, Riley? But what were you going to say?
Like steam.
Steam is a gas too. So observable properties means something that we can see, notice, or touch with our senses. And scientists use these properties to help describe and explain different materials and how they behave. So the first thing that we're going to do is, I have a book here. Would you say this is a solid, liquid, or a gas?
Liquid.
Close.
Solid.
Anyone else? Solid. It's a solid. Do you know why it's a solid? It's because they're easy to spot because they keep their shape and their volume. So if I put it on the desk, for example, it doesn't change its shape. It just stays there. So solids, they don't flow and they don't spread out like a liquid would. And I'll show you a live demonstration of that. If I was to pour water into the bottle, what do you notice it doing? Do you notice it doing anything in particular? It's filling up.
It's loud.
It's loud.
It's pouring.
It's pouring. So as you can see, as the water was going into the bottle, it was spreading out. The volume of the liquid stayed the same, but unlike solids, liquids don't have a fixed shape. So the same goes for if I poured it into a container, it would take the shape of a container, the same way it took the shape of the bottle. So the liquids can flow and move around, but the amount, like I just mentioned, the volume will always stay the same no matter what. So gases are a little bit trickier because often we can't see them, but we can observe their effects. So what is the main difference that you would say is if you were to compare a gas to a solid and a liquid? So we mentioned how a solid had a fixed shape. We mentioned how liquids don't have a fixed shape, but they do keep their volume. What would you say about gases?
You can't see them.
You can't see them. They don't have a fixed shape, nor a fixed volume. They just spread out and fill up whatever they're in.
Oh.
So I don't have an example for that, but if I was to have a balloon and I filled it with air, if I was to let it go, what do you think would happen?
The air would go out of it. Into
The
the
air
room.
would go out of it and spread out. Riley, you're so amazing. Give yourself a clap. So gases, I'll also add on to that, are also compressible, meaning we can squash them into a smaller space, unlike solids and liquids. So let's think about these three together. Solids can keep both their shape and volume. Liquids, they can keep their volume but not their shape. And gases keep neither their shape or their volume. To help us compare them, we're going to use a Venn diagram. So
What's a Venn diagram?
a Venn diagram is a thinking tool that will help us see the similarities and the differences. So what you guys are going to do in pairs is you're going to list some solids in this circle, some gases in this circle, and some liquids in this circle. In the circles where they overlap, you're going to write the similarities that those two things share. So for example, I would write potentially a sponge in this circle because it shares the properties of both a solid and a liquid, because they're not quite solid and hard, but they're quite flexible as well, but they are technically a solid. So what we just mentioned earlier about the properties of each, the solid and the liquid and the gas, what were some of the most defining features of a solid? Just to help us remember what a solid is.
It stays the same.
It stays the same. So if you guys have difficulties with understanding what a solid is, we'll write in brackets what Riley just mentioned, that it stays solid. And we'll do the same for liquid, we'll do the same for gas. So if I could borrow a pen, just so I can demonstrate that. Underneath solids, we'll write stays the same. Liquids flow. And gases spread. So I'm going to hand out these diagrams to each of you. You're going to work your pens. And you're going to have 2 minutes to list as many
Thank you, Mr. Steele.
Thank you.
examples as you can. So go ahead and do that, and I'll walk around and assist anyone that needs help. I'll time the 2 minutes now. Go ahead.
Sorry, Mr. Stephen.
Sorry,
Are we
yes.
doing examples?
You're doing examples
Okay.
of solids, of liquids, of gases, and if you could decide it, you're going to write a observable property of that. Doesn't need to be a sentence, it can just be one word. So for example, brick, what do you think when you think of a brick? Oh,
Hard,
perfect. And then you do the same for liquids,
Liquid.
gases.
Coke,
So, what would be another example of a gas? Because I know it's steam, but I don't know any others.
air,
Oxygen.
Oxygen.
Oxygen's a good one.
CO2.
If you want to get real
That
technical with it,
is
yes.
Oxygen diffuser.
No, it's carbon dioxide.
Everyone settle down. Settle down. Would we like more time?
No.
Yes, please. Just a little bit.
Mr. Stephen, I can't think of anything that are both
Can't think of any that are both.
in here.
Steam.
Are you trying to asking Jazz what she thinks?
Jazz, what do you think?
Wouldn't it be steam? Because you can see the condensation, but like,
Oh, I understand.
you know?
Thank you for
But
your
how can
help,
it be a solid
Jazz.
and a liquid?
A liquid and a gas.
Liquid and a gas.
But it can't be both.
Yeah, the
We're talking about
condensation.
observable property.
Observable properties.
Observable properties, that's right.
Oobleck can be a liquid and a
Oh.
solid. Oobleck.
1 more minute.
Connor's not doing anything, Mr. Stephen.
I'm giving Mr. Steven feedback.
I'm finished, sir.
I'm done.
Amazing. Okay, who would like to share what they've written in their Venn diagram
I think
first?
Connor can.
Connor can go last. I think Connor still needs a little bit more filling out. Yes, Sophia?
So I put that a solid is a brick and a liquid is Coke and gas is CO2.
Amazing. It's really good. Riley?
We said things like pens, tables, chairs, cars, all solids.
Mm-hmm.
And liquids are water and like apple juice. And gas is air, oxygen, and steam.
Awesome. Good job. And Connor? What have you written down?
Yeah, Connor.
I struggled with this one.
That's okay.
Might need some extra help.
Yes, Evie?
I said that the overlapping between a solid and a liquid could be a snow cone or a slushy.
You're thinking outside the box
Oh,
there.
I like slushy.
Ooh, I think the whole class likes that.
Evie's clever.
Evie is clever, but we're all clever in our own ways. Isn't that right, Connor? Okay, so before you go off on your own, before you do all your activities,
That's bad.
I'm just going to list the success criteria up on the board so everyone understands what we're going to do. So in order to get the 1 star, you must be able to list at least 3 examples of each state of matter. So when I say state of matter, I mean solids, liquids, gases, and attempt to describe the properties. Okay, so you don't have to get it right, just have a go at it, and I'll help if you need. To get 2 stars, it's quite similar. You just have to find 5 examples of each state of matter and correctly identify the describable, observable properties. And for the 3 stars, you've got to find 7 examples. All right, let's do it.